RsNLME, it's a Certara supported environment for pharmacometric work in R. So it's a collection of open source packages, some of which require the Certara NLME engine. Other parts of these packages do not. You can use them with non-mem, for example. But the packages together support pharmacometric modeling using our NLME engine and our pharmacometrics modeling language, PML, which is the same language used as Win-on-Lin, throughout the Phoenix platform, directly from the R command line. We've taken that syntax, kind of understanding that, R is hard, and supported key workflow steps in the pharmacometric workflow with intuitive Shiny apps, which allow you to do the task, but also generate R code as either a final product or perhaps a starting point for something more custom. The packages, this kind of will look like tidyverse type nomenclature that was intentional because the analogy definitely is there. It's a collection of packages that work together. And we have a package down documentation for more information. There's vignettes in here, links to other packages. So why do we build this, right? And really it was to extend the capability of our PMX modeling tools into R. The popularity of R just continues to grow no matter how you look at it. This is a slide from 2019, ACCP, Mark Assingway, made this presentation of this funnel-shaped expansion of open source solutions. We built it to be able to harness the flexibility and efficiency that is achievable with open source tools. The way we did this is, we built these packages to work with our NLME engine, but we're also making a contribution through packages that, don't need our engine. The whole thing behind it was to help users and organizations realize the benefits of R in their PMX workflows, right? R is hard. I think all of us who've taken the time to learn it would agree with that. And what RsNLME does is it helps lower the learning curve. We're offering it free to students and academia. And for organizations, the introduction of R actually allows Certara to provide a combination of tools that we support that an organization can implement, and that will support the full spectrum of their analyst skill sets. So with Phoenix, you could have a junior Win-on-Lin modeler doing his work. However, if you have someone progressing up through into a modeling role, they can maybe start in Phoenix NLME. When it's time to jump to R, they don't have to learn another syntax or another tool. They can use PML and R now with RsNLME, and we support it. And then finally, we're building some workflow support tools beyond the core analysis, and we'll show you that through our reporting user interface and VPC user interface. And these are configurable to essentially downstream requirements. If your regulatory documentation group has specifics for fonts and this type of thing in their Word documents, you can actually configure our tools to meet those, at the point that you generate them. Big picture, it's about Certara providing professional tools for professional development organizations, right? And by that, I mean they're multidimensional. Really, it's about capability, scalability, stability, and support. Capability being features that really support the easiest, but also the most advanced job requirements. And that's where all the flexibility of R comes in. The way I look at this is that, with RsNLME, we're able to kind of help users, identify what packages within the open source community are going to help. We can integrate with them, either via custom script or, through building some of the functionality to our own open source packages to really allow that off-road, which is really the nature of exploratory drug development. So scalability, again, I mentioned the solutions growing with an individual and organization. I think the stability came up at the R and Pharma, right? When you have users, business users that build solutions, what if they leave? It's also difficult to, get people to work on things when they get old, right? The new solutions are exciting. You can always recruit people to help you. But if they're established and it's time for like a menial upgrade or something, right? It's hard to get a business user to prioritize that over their own work. Certara supporting this kind of obliviates that requirement. So, I say we don't leave individuals or organizations stranded. And then finally, support. Our support organization is building capability to be able to help organizations with the R solutions that we integrate with. So I'll stop there, turn it over to Muli for the Pirana demo.
Thanks, Keith. Piranha was first developed by Ron Kaiser. It gives you a flexibility of using R by itself, or if someone who is starting with R, they're not sure about, how I'm going to write a code for this model. This is a good place to start for the user as well. As you could see here, I've done a couple of models here. I just want to quickly show, this is my data set, what I have. So that can be imported using a standard format here. And then if you want to, if you have multiple projects, the other option with Piranha RsNLME is going to be saving your project. So once you save the project the way you want, you can just keep navigating between these two projects. We got this option of MMDL model. That's when the RsNLME comes in. If it's a non-mem, it goes into MOD or CTL file. Building a model is pretty simple. So all you need to do is once you have the data set in, you start building your model here. So this is a GUI based one. As I mentioned earlier, this is good for some users who's developing the skills in R, but then it gives a combination of NLME overlook and then RsNLME as well. So you've got an option of PML code, and then you can simultaneously keep generating the RsNLME code. So these models can be directly copied, and you can use R instead of Piranha. So it's just like what we have in our Phoenix NLME engines. So it's just going to be a first order model, and then once you keep clicking next, what happens is it takes you through the series of steps. So where you can define your covariates. In this case, I've got two covariates, and you can just add your covariates here, and then you got your fixed effects for your initial estimates, and then the random effects can be added as well. So once you have developed the model, you do have other options like running an initial estimates on the model, which basically brings another GUI for you. So in this case, you've got these options, and then you can adjust your initial estimates, and it does comes with multiple options, like you can overlay the whole structure of it, or you could have an individual subject, and then you could use this meta model to execute a meta model, which brings another GUI shiny app for you, and it's something similar to what you see in Phoenix NLME. The exciting function about this is particular the one which we developed with RsNLME is about running reports. So once you have created these reports, it gives a functionality of ggplots. So where you have all these options to customize your plots. And as you could see, the plots can be customized, and this can be changed, and it can be edited to the way you want it. And you do have all other options if you want to add lines, or some of these options which are available, which involves more time for you to write a code. Once you have selected some of these plots and tables, what you could do is you could tag them for your reports. In this case, I'm just going to tag a couple of reports, the theta table, and then another basic goodness of it. Once it's all being tagged, I could see all my GUI, the reports, the tagged reports coming up here, and simultaneously generates the R scripts for me, R code for me. So this is something which would be handy for you to develop, and you can, this can be customized to your needs. So once this has been done, what I could do is I could use a report function to generate a report by just dragging and dropping. And I do have an option of producing it as an HTML or a PDF document, or or a PDF or a document folder. And also it brings down with the R Markdown scripts. You could download it as a R Markdown, or you could download it as a report. Once I have downloaded the report, so it's all available in the report section. I downloaded this as an HTML, so I do have all these options, and if it can be customized to your needs as well. Maybe I'll hand over to Keith again, so he can take you through the whole process of building the model using R.
We've enhanced Piranha to be able to work with NLME models. It still works with non-mem. The new features are this model results UI that Muli showed you that allows you to point and click at diagnostic plots, customize them, and then tag them for inclusion in an R Markdown report. That, I think, is going to be very interesting to our experts who are able to get a report out, 2 days after their analysis is done, in terms of using our markdown. You do not need Piranha to work with RSpeak's NLME from the command line. What Piranha gives you is kind of a bridge into that R environment, but it also provides some harmonization, right, from an organizational standpoint. When you have users working with tools like non-mem and NLME, R, right? How they store their run outputs. Piranha is enforcing kind of a harmonized standard for how models are organized. And that's what you get out of Piranha, as well as a nice kind of user interface to do common kind of diagnostics. So, there's a lot of different options, and we've tried to provide a variety of ways of doing things that can support how different users may want to work. But what I'm going to do now is jump right over to the command line. So this is essentially if I'm going to approach a RSpeak NLME analysis in R, this is how I would do it. I would start by setting a working directory, and I have a folder that I set up on my hard drive. I source environment setup. This is just loading libraries and defining what we call hosts. So a host is saying, okay, I'm going to use my CPU on my PC with 1 core or 4 cores with MPI threading, that kind of thing. I'm not going to, get into that detail right now. But now I've loaded my Certora packages. And again, these are open source packages, Certora model results, just like any other package. They're not available on CRAN, but we do make them available through a Certora CRAN-like service, so anyone can get at them. Here I'm going to read my data set in. We can look at that, with ggplot, and of course you have the full functionality of ggplot. This is just a 2-dose PK/PD data set and 100 subjects. Of course, you can bring in faceting. If you haven't checked out GD Quick EDA, I'd highly recommend you do. It's a Shiny app that essentially, it's a ggplot2 Shiny app. So it returns code for doing sophisticated plots, really quite useful for exploratory data analysis. So I have my data set. Looks kind of too compartmental-ish, right? So I'm going to use just direct model syntax in the RSpeak's NLME function to create this model. I'm going to define a model name, and that essentially says, okay, 2-compartment ID is the name of the folder that I'm going to store this model output in. And then I'm going to use this PK model function and specify some arguments to it. PK model is only one of the functions. There's also Emax, PK Emax, PK indirect, and it's the same syntax as you can access through that model builder that Muli showed you. But if I just run this to create PK model, we can print that model, and you see the model object gives you a summary of it's a PK model, how it's parameterized. This, again, is the PML. It is exactly the same PML that you'd use if you were doing individual wind island modeling or modeling in NLME and in Phoenix. That's the model object. The next step would be to set your initial parameters. So you see by default, they're all 1. So there's a collection of functions, structural parameter, fixed effects, random effects. You can always jump to the model builder UI if you don't know that syntax, and I'll show you how to do that. And that's either through Piranha or through the command line. So here you see I've updated my fixed effects and random effects. I can add some covariates. Here, I'll just add them to the model. I won't assign them to any parameters yet. And I do that to make them available for diagnostics. Here I can print the model again. So now I have my F covariate statements in the PML. And of course, again, if you need help with the code, this is the command you'd run. You just launch the model builder UI with the input data set, and then assigning a model name. Notice I've used a little bit different one so it doesn't conflict with the one above, but I can run that. And now this will bring up this same user interface. And again, this is, if you want a PK indirect model with 3 compartments, Michaelis-Menten elimination, and a delay function, for your absorption, here's your PML code. So if you don't know how to write it, you can always come to this interface to essentially learn the code. And as Muli mentioned, you can always get at that core RsNLME code, which can be then taken. I could copy this and bring it right back into my R session. You can always look at your data set. We tried to build, some real useful helper functions into the script. So PML is quite a flexible language. The idea is that a company can implement this and then users can work the way they like. So I fit the model, and you see the console gives you like an output of the iteration steps and then a message that the run was successful and generates some output. This output is structured as it was for the Phoenix NLME GUI. So it's not like you define like a specific table statement in non-mem, rather a set of predefined outputs are generated by the NLME engine. And then what we do with those outputs is we actually have a function called expose NLME that takes these outputs and creates an expose database object that you can then run expose for diagnostics against. So it does require the expose for package and some knowledge about how to use that. But again, it's ggplot based, and it is incredibly flexible if you take the time to learn it. So if I print the fit, right, again, this is just console output of the print, quick and dirty look, gives you a summary of your parameters. Here now, what I'm going to do is create an expose database object. And don't let the syntax, confuse you. This directory, this expose NLME actually expects a directory path where the folder is, where the modeling output is, and a model name. So this model at model info work directory, that's just extracting the directory from the model object itself. You can also specify the directory itself. We'll create the expose database object. And then what you can do is run expose functions. So the DV versus pred, that's an expose function. And you have the flexibility with the template titles and all the arguments that you can provide to that command. So, DV versus pred, right? DV versus IPred. You can do things like create a group of objects and then use ggArrange to get them on one plot. And ggArrange, that's not Certara functionality or anything, right? These are just useful open source approaches to do custom things, right? When you have to go off road. Because it's ggplot2 based, you can pull in like the faceting that's part of expose, but if you want to add layers, like you would do with any ggplot, you could do that. So this just kind of builds on, I did a DV versus pred, now I facet by sex. You can see our model now, it's kind of under predicting for males and over predicting for females, right? The type argument is point smooth lines. So if we want to get rid of the L and PSL, right, you can get rid of the lines. We have a Certara theme that looks nice for us. You're free to define your own themes, and the theme would cover like font sizes, colors, background, that kind of stuff. And then of course you always have like the other ggplot stuff you can throw at the plot. So xlim, ylim would be one example, but just tremendous flexibility in that package. Here's a filter example. So I can send that XP object to a filter statement, and that's from dplyr to look at weights greater than 100. And then push that to DV versus pred. So the point here is that we've implemented piping in the syntax, to stay up to date with convention in the tidyverse. So here's a plot of weight greater than 100. See, we definitely have some kind of weight covariate in our model. Again, these are just examples. Highlight outliers. So here we create a conditional weighted residual flag. So the default res versus pred, There is a res type argument. See it res equals CWRES. By default, it's conditional weighted residuals. You can do IWRES, WRES. Again, that's a kind of an expose package knowledge thing, but very, very flexible. Here we just create a flag variable and then turn the points red when they exceed the criteria that we set. Annotations are possible. Just trying to give common kind of use cases. Here we have a LLOQ. And of course, you can also, if you have a set of diagnostics that you want to run as you push through your overall modeling, right? Here I've defined a function called my goodness of fits, right? And I've said, okay, this is a function of XP. So I'm going to feed it an XP object. And then I'm just going to generate, the plots that I specify in here. Again, this is only an example. So the next thing I will do quickly is just, again, we have some gender issue in the model, right? So I'm going to run a model now with a gender effect on clearance. So to do that, I'd create a new model name. Here I call it model gender or model sex CL. That's free text, right? If you're using Piranha, Piranha is going to be kind of controlling that for you and for your function, which again, if I was like a department head, I'd probably be wanting my group to use Piranha so that when people come and go, you could easily figure out what the heck they did instead of trying to troll through their, R and non-mem code. But here I'm creating a model called model sex, and I'm copying the base model, accepting all effects. And then I'm going to use this add covariate function to add gender to clearance. If you don't know that syntax, you can always go back to the model builder and get an example. Now we'll print the model, and we see the clearance has a gender effect on it. This syntax is a logical check. So if sex equals 1, this is equal to 1. If not, it's equal to 0. So it drops out. And therefore, the DCLD sex 1 value is a kind of a scale factor for gender. I'll fit this model. So this model will fit. And then what I'm going to do is open up the results UI and show you how you can actually be building a report in parallel to your analysis. But first, again, I'll create an XP2 database object, right? And very quickly I could run my, if I just clear these out, clear them all, I can rerun my GOFs on the second XP2 object. So now I have another set of diagnostics for my gender clearance, and I can go back and maybe look at that same DV versus IPRED, by gender. Now it looks a bit better. We're still, still some going off, but I think there was a volume, gender effect there. So very quick. I think Gmuli showed you the results UI. We also have a VPC results UI that I wanted to show you, and the reporting functionality is similar between the two. To do a VPC, essentially, again, what we're going to do is copy the model. In here, I'll do a VPC of the model with sex on clearance, accept all effects true, sets all the fixed and random effects parameters to the, to the values for the simulation. I can hit run. I won't bother printing it. I've showed that before. And then what I'm going to do is use the VPC model command to run a VPC. Now there are engine parameters settings you can define for VPC fits, including the number of replications, and there's a whole set of them that you can get through at the package documentation. But here I'll just use the default. I think it generates 100 replicates, so it's very quick. And then because we built the VPC results UI to work with either NLME or non-mem outputs, what it expects as input is the observed data set that was used for the VPC, as well as the simulated data set, which has all the replicates in it. And for RsNLME, we can pull those from the model object itself, and it's always pred check 0. Here you get a sense for that, kind of organization of that. So I'm going to capture my observed and simulated data. And then what I'm going to do is feed that into the VPC results UI. And this is, again, an open source package that will work with non-mem or NLME, and it expects and that's simulated and observed data sets. And then you define basically your variables, Y variable and X variable. IVAR is the NLME term for time. If you did a stratified VPC, you can, look at stratified VPCs. Here, of course, there's default values for quantiles, confidence interval, but I'll look at the controls. So we support both binning methods, several binning methods, as well as the new binless VPC method that Chris Jamson that uses additive quantile regression to select bins. I'll just show you a couple of examples. So maybe pick k-means, and we can plot, that VPC immediately. If the aspect ratio doesn't look nice, you can drag it and resize it. Of course, there's all different styles that you can apply: dash lines, solid lines, long dash, right, solid. I think this should be pretty straightforward. Very quick layout. You can do, log Y, log X. Very quick facet on the quantiles. You might want to do that. And of course, under display, you can modify the text names for the various parts of the plot. So the title, subtitle, caption. By default, it's using the Certara theme. However, you can modify the fonts, the sizes to whatever your documentation group requires, if that's the case, or whatever you think looks nice, and then save that theme when you exit the product. Of course, there's bin lines, arguments. So I'm going to go ahead and tag this VPC plot 1. I'll tag that, and then maybe what I'll do is I'll just run a binless VPC and plot that, and I'll tag that. Binless takes a bit longer because, again, it's doing that regression. So yeah, they almost look identical, but I'll tag that. And then I can go to my tagged. And again, this code here, right? I could take this right directly and copy that into my R environment. And I've done that. When you have a Shiny app open, it locks your R environment. So if I go back here, right, you'll see I copied this code in. It's the same, kind of the same code as we're looking at now. I just can't run it now because it's, it's listening. You can also get a R script out of this. You can get the report itself or the R markdown in HTML or document. Download report. Rendering report. Here we go. A lot of our consultants are delivering HTML documents as their initial report analysis findings for first review of clients, because you can make a very, very dense document with that. So, right, you could have like an intro and a methods, and then just a list of tags like this. So on one page, you could have, here's the, base model diagnostics, and here's the key outputs, and you can color code these things. And I don't have an example of one of those reports, but it, explaining it, I hope it gives you a sense for, why somebody might want to use HTML. It's a very, very effective way to provide like a very dense summary of a modeling exercise to a clinical team, for example, instead of a 500-page PowerPoint presentation. You can download the R Markdown code. I'll show you that in a minute. I'm going to exit here. I'm just not going to save anything. Exit, and then I'll go back to my R session. And so this is the code, right, from the VPC. And it uses the VPC package. So you're creating the VPC object, and then you're using a ggplot to create that plot. If I run this, again, directly from the Shiny app. So you don't have to know how to write this code yourself. It's running the binless one, which is why it takes a bit. Here it is. And then, of course, you could go in, which is going to be, I think, in my mind, the primary use case, and customize this however you like. It gives you a hint. If you forget what geome or scale fill manual was, well, here's an example of how to write that. And that's where, like in my experience, right, if you didn't know that, it became a Google search. Now it's better because there's pharmacometrics, kind of focus people, users in R, but in the old days, it was hard to find examples or beg somebody who's better than you with R, right, for help. Now the GUI can provide that. And then finally, if I look in the files, right, I mentioned that Should go to my working directory here. This would be the R Markdown script that the tool generates. So if you're familiar with R Markdown, this will look familiar to you. Basically, you're able to then add text around the code, what are called chunks, which basically do the analysis. So R Markdown is a way to incorporate the code itself within text you supply around the code to create a document. But we can do things like, I have this R Markdown now that I included in my project. I can just render this command as a Word document, and that'll just take a minute to run because it's rerunning the that VPC. But in a minute it'll be create. It says, okay, you have this VPC report doc, and I can open that up. And here's my this time it's a Word document, not HTML. So I think that is the conclusion of my demo. Maybe I have just a little bit of time. I can just run the results UI. One of the things Mooley didn't show. So recall I created two models, the base model, which I call model, and the gender on clearance, the model SexCL. The results UI also allows you to compare models. So if I go here and, pick DV versus Pred, right, resize it here, you can very quickly go between 2 or 3 or however many models you want to include in that call to results UI. In Piranha, you would click on the models and hit Control to select more than one. Here you specify it to the argument itself. We quickly glossed over the table. So again, the tables in R can be challenging. We've used the flex table package, and again, here's the code for flex table. You want to see how to create maybe a custom table within your R Markdown. It's a good starting point. So yeah, I'll stop there.